Hi, welcome to Zona Mechanica. There is an MCQ on friction. The figure at the margin indicates the weightage of the question, that is 1 mark. There is a wardrobe of 4 meter high, 2 meter wide, and 2 meter deep. And the wardrobe is resting on a level floor. A force P is applied at the mid height, that is through the CG, so as to tip the wardrobe about the point Q without slipping. So this is the constant without slipping. The question is, what are the minimum values of the force P in Newton and the static coefficient of friction mu between the floor and the wardrobe respectively? So there are four options. This is the free body diagram of the wardrobe. This is the force P acting and this is the weight acting here. So there will be a normal reaction. Okay, so this is in, and once we apply an external force in the horizontal direction, there will be opposite frictional resistance. This is F. So if we increase the value of P gradually, the value of frictional resistance will also increase, and up to the limiting friction, that is the maximum friction that can be offered by the surface. So up to that point, these two will be proportional and equal. Okay, so P is equal to F up to the limiting friction. So beyond this value, let's suppose this is the limiting friction F. So beyond this value, if we apply more force, I mean greater than F, then it will slide down. The frictional resistance won't be able to keep the wardrobe at rest, so it will slide down. So this is the constant without slipping. This is the condition. Okay, so maximum force that we can apply will be equal to F. So these two forces, equal and opposite parallel forces, these two will create a couple. That couple will try to tip the wardrobe. Okay, this is the point Q. So it will try to tip the wardrobe about Q. Okay, so our constant, as per the constant, to satisfy this condition without slipping, if we want to tip, then it will be equal to the limiting friction. So as we know from the friction formula, that F is equal to mu into N. Mu is the coefficient of static friction. Okay, so from here we can write down N is equal to, this is 100 G into mu. So again, G is 9.81 into mu. So that is 981 into mu. See, as we know that any rough surface, the value of mu is less than 1. So if it is less than 1, then the value of P not greater than 981, right? Not greater than 981. So this is one condition. that the value of P is not greater than 981. So now we will check which option is satisfying this relation. That means if we put 0.5 as the value of mu, then how much is coming the value of P? So when mu is equal to 0.5, P is equal to 981 into 0.5, that is equal to 490.5. Okay, so it is satisfying. Again we can check this one. So here also the value of mu is this and it is given 981, so this is wrong. And if we check these two values also, if we put 0.15 as the value of mu, then it won't give 1000.5. And also if we put 0.25 as the value of mu, it won't give 1000.5. so these two are also wrong. Okay, so only the option A is satisfied with this condition. Okay, so the option A is the correct answer. Okay.